So for the sake of space and maintenance, a database must be normalized. Well, that kind of makes reporting a little more difficult. If you want to see a list of employees and the details of where they work, you've got to run 2 queries and look for the corresponding field in each table, and then put them together. Well, you can actually view all of this information in one query, and that's what you will get to see. Okay, I'm giving myself the maximum amount of room since we're working with 2 tables at once. Let's start off by looking at the employee table. 7 fields, 12 records. Location ID 1 is the most popular. Let's look at the location table. Location ID 1 is Seattle. All the details and all the other locations are listed. Running both of them at once solves a few riddles. We know that Alex Adams works in Seattle. Barry Brown works in Seattle. Lee works in Boston. But what if I wanted the word Seattle and all corresponding locations to appear over here to the right of the employee record? How do we put 2 tables in one from clause? Well, we can do this if we know how these tables relate, and we do. We know they both have a location ID. But to be more specific, these are 2 different fields. This one is the employee.location ID, and this one is the location.location ID field. To properly identify a field, you need to specify the table name, then a dot, and then the field name. Let's put both of these tables in the same from clause, and we're going to separate them with the words inner join. Inner came from equa, which means equal. These 2 tables have something they equate on, and you can relate them to. So we specify that these 2 tables are related, but we haven't been specific on just how they're related to each other in SQL Server. That's where the on clause comes in. We're going to say that the employee table has a location ID field, which corresponds to the location table's location ID field. Run this query and notice the location fields appear to the right of each matching record of a location ID found in the employee table, and you get a complete report in one view. We know when we query just the employee table, we get 12 records. But after we do this join, we only see 11 records in our result set. This is because with an inner join, it only shows records where both tables match. What if we wanted to see all employees, regardless of if they have a matching location ID in the location table or not? If you want to find matching and non-matching information from 2 tables, you need to use what is known as an outer join. To demonstrate this technique a little more clearly, we're going to put both tables in the same line after the from clause. We have one table on the left of the join and another table on the right of the join. Now, which table do we want to become the dominant table, the table that should always show its records? If we want the table on the left to always show its records, even if it doesn't find a match on the right, just change it to left outer join. Run this query, and we get John Marshbank. In this result set, the null values you see next to John Marshbank's name means no records were found in the location table. We may also remember we have 4 locations: Seattle, Chicago, Boston, and Spokane. There is actually one location that has no employees. Notice Chicago does not appear in this result. Well, what if we weren't doing an employee report, but a location report? We want to see all locations, even if there's no employee associated with that location. We would have to use an outer join. The table on the right needs to become the dominant table. So you would type the words right outer join. And notice 2 things. Number 1, we have Chicago with no employees, and now your result set is ordered by the natural sort of the location table, which is by location ID. There is one other type of join that allows both tables to show all records, and that is a full outer join, which at one time was called a right-left join. When you execute this, you get all employees even if they have no location, and all locations even if there is no employee working there. If the report said show last name, first name, city, and state, we can now itemize our fields safely because we know that all of the tables that the fields need are already present in your from and your join. So we will say first name, last name, city, and state, and execute. When you do a select star, you are asking for all fields from all tables. We have 11 fields because we're pulling in 7 fields from the employee table and 4 from the location table. Notice the location ID field appears to be listed twice. The actuality is the first one is the employee.locationID field and the second one is the location.locationID field. Let's lay the foundation for an important question. We have a perfectly good running query with just 4 of the 11 fields, 2 fields from the employee and 2 fields from the location. If I were to simply list location ID, would SQL Server try to pull out the employee.locationID or the latter location.locationID? We haven't specified. Which one does it choose? Well, let's execute to test. Playing conservative, SQL doesn't want to take any chances with what you meant. It says, hey, I found a location ID field in both tables. You haven't said exactly which one it is. It's ambiguous, so it's not going to run. Let's say I would like the employee.locationID field. With that clarification, the query runs just fine. Sometimes you need to fully qualify fields in the select, in the on, or even in the where clause. If you wanted to be really explicit, you could qualify every field. This is the employee.firstname field. This is the employee.lastname field. This is the location.city field. And this is the location.state field. This query runs just fine. In most situations, 2 tables would have maybe 1, 2, or up to 3 fields in common, so all of the rest of the fields would be uniquely named by using their simple name. Why is it considered a good practice and a safe practice to fully qualify every field, even if that field is unique to that table only? Well, as you will learn in Chapter 6, it's possible to add new fields in tables where one didn't exist before. Right now, the location table is the only table that has the state field. But state could be in another table, like the employee table. The state of the employee, for example, could mean, are they in a hired state, a fired state, a pending state, or a leave of absence state? Take the location.state qualifier out of the select list right now because SQL can easily figure out how to run this query. Now, go to the employee table and modify it by adding a brand new field called state. Save the table changes and check the table to see that the field is there. We can see that the employee table also has a state field. Now this query, which maybe you built a year ago and has been running every day and has been running fine, all of a sudden fails. You haven't changed the code of this query, but because state is now ambiguously referenced, the way to fix it is to say which state field it is. Let's say it's the location.state field. So as you see, to make your query code robust and not fragile to future changes, it's a good idea to fully qualify all of the fields you see and reference in your query. There's a drawback to this extra work. How many times do I have to type the word employee as a qualifier? That's a lot of typing. Some tables are 25 or more letters long. This lab will show you how to save typing while still giving you the benefits of fully qualifying your fields. Let's go back to the query that joined the employee and the location table and just pulled in 4 fields. Select star from employee inner join location on employee.locationID equals location.locationID and execute. Okay, too many fields. Let's pull in first name, last name, city, and state. Nice. Now what we're going to do is fully qualify all of the fields and all of the joins everywhere, except we don't want to type in employee and location over again. Well, what we can do is look at the from clause. The from clause is the core of the query. Whatever you set there dictates how the rest of the query will run. So we're going to call the employee table E. We're going to call the location table L. Now we can say in our join that E.locationID is equal to L.locationID. And the first name is from the E table alias, last name is from the E table alias, city is from the L table alias, state is from the L table alias, and it runs with far less typing. Now this strategy does not rename your table. Your tables are still called employee and location. For the sake of this query, you refer to tables by the alias, like where L.city equals Seattle. For the sake of referencing fully qualified fields in your select, in your on, in your where, and other clauses that would need those fields, you can now save a significant amount of typing and scripting. Lab 1.2, Skill Check 1. In one query, you want to see the employees and the cities where they work. You know the two tables share a common location ID field. Query both of these JProCo tables by joining them on this field. Your field select list should include only first name, last name, city, and state. Alias the employee table as EM and the location table as LO. Use two-part names in all areas of your query. When you're done, your results should resemble the figure you see here. Skill Check 2. Open a query window to the JProCo database. Write a query that shows the list of all grants and the first and last names of the employees who acquired them. If the grant was not found by an employee, we still want to see a null first and last name. To do this, join the employee and grant tables. Show the first name, last name, grant name, and amount fields. Alias the employee table as EM and the grant table as GR. Use two-part names in all areas of your query. When you're done, your results should resemble the figure you see here.